Hi, everybody. Okay, I think we're going to get started here. My name is Ian Withrow. I run the product management team for all of the end-user monitoring agents at AppDynamics. As a PM, you build lots of different kinds of features. Some features, you do because the competitor has it and you want to have it too. Some features, all your customers are asking for it. Sometimes you even have to do a feature to get a deal, although you try and avoid doing that. But you always hope that you're at least building one feature that isn't about what the market wants now, but where you think the market is going to want next year and the coming years. SinglePage Apps is something that we've been thinking about for quite some time, working on with a few of some early adopter customers of ours. And I'm really pleased to see that over the past 6 months, demand and interest and inquiries about SinglePage App support has really dramatically picked up at AppDynamics. So that's why we're going to have this talk today. I'm going to cover, high level what SinglePage Apps are. I know many of you may know that, but just so we're on the same page. Talk a little bit about kind of why I've heard customers say they're using them, what they're getting out of them. And then I'll kind of show and tell you about AppDynamics' solution. So first up, SinglePage Apps, fundamentally the concept is you're loading the application code onto the user's browser in the first page view. So, and then once that's loaded, all the browser needs to do for subsequent user requests is dynamically fetch the content it needs to update or re-render the view using something typically like Ajax. So to the user, it actually forms kind of a sleight of hand. It looks like it's a traditional web app. There are different page views. You're loading. You're clicking through a sequence of things. But under the covers, there is no page event. The spinner in the top right-hand corner, i.e. is not twirling. That doesn't happen with a SinglePage app. Here's kind of the architectural view of that. Basically, on the left, you see a traditional app here. So you've got a user. He clicks. Server basically has all the smarts here. It sends the browser the instructions, and the browser just follows those instructions to display that to the end user. The user clicks another link. Browser goes and talks to the server, say, what should I do? Server sends that back, and it's displayed to the user. Repeat. Now, with the SinglePage app framework, on the right, you see there is that first initial request, but a much larger set of instructions are downloaded. Essentially, what you've done is you've shifted your app server code onto the client. And this is what comes down in the initial page view. And as users click around, it can load new views, possibly if there's a good caching strategy without requesting anything from the back end. But where there's a need, it'll send a request just for the bits that needs to be loaded. Here's an example of a SinglePage app, USA Today. If you go to this website, after the first load, you'll find if you click on these stories, it opens up a new view. Or if you click around on some of these different tabs, it shifts a view just like you would expect for a nav event, but under the covers, there isn't actually a new page request going on. So if you're curious to see one in action, this is an example you can check out. So why do developers do this? Well, I'd be remiss if I said that it wasn't cool. Like a lot of developers are picking this up. There's definitely some faddish elements going on with the different frameworks and their rise and fall. But the way the developers often sell this to management and the business is that SinglePage apps, it is possible to build a much more dynamic and rich experience and a more responsive experience with these frameworks. So the user actually benefits in the end. Although, like any tool, you can mess this up and do it worse. Let's talk about kind of the changes in technology that has made this shift possible. First up, clients are a lot more powerful. So even a really old browser can do web browsing with ease, with spare capacity. And so as I was talking about earlier, your strategy with a SinglePage app is you're actually shifting code and processing down to the client. So you're actually distributing your logic to available compute that exists on user systems. So that's powerful. Even on mobile devices, compute power is rapidly expanded. So if you look at iPhone processing power, as I'm showing here, it's substantially increasing with each generation, such that even iPhones can readily handle SinglePage apps. In fact, as a consequence of this, SinglePage app frameworks have become really powerful with native mobile app developers. So often in a native app, you find there's parts of your application or even all of your application that you want to load with what's called a web view. So it's basically using the browser's the mobile app's web browser in the app to load something for the user. And things like Angular have been super popular in this community to do that. The reason being is that single-page apps can potentially send a lot less data. So as we discussed, in that initial load, you're pulling down all the logic. But then in subsequent requests, you're just fetching what you need. Potentially with a good caching strategy, you don't even need to fetch a lot of things. And that's great for mobile apps because wireless has and will likely continue to be the bottleneck for the mobile experience. And so you can use that scarce resource much better. Even though networks are getting faster, wireless is never going to keep up with wired from a performance perspective. Another reason is the skill sets available. Now, admittedly, this is a completely not scientific way of assessing the market. But what I did is I quickly went out and Googled Indeed for a couple of skill sets. And while you may quibble with the relative ranking of these, what it shows is that JavaScript is just as much a highly fungible skill as things like .NET and Java out there. So you can hire people to do this work. As a result, where there is demand, there is supply. And we've seen a proliferation of different frameworks doing the whole single-page app thing themselves or doing a subset of that. There's lots of tools out there. So developers can kind of pick and choose what works for them. That said, definitely some of the biggest frameworks we've seen, Ember, Angular, Backbone, and React, those seem to be kind of the standard off-the-shelf packages that people like to use. And they have some very common core features. So all these tend to use the MVC model of application development. And one of the nice attributes of this is as you are updating your model with UI binding, basically the view changes to match the model. So you're not needing to, as a developer, understand how to micromanage the DOM. The framework is going to do that for you. Another good thing, developers like reusable code. That's pretty key. So this is a very common, important feature. For example, Angular's directive capability. It basically lets you save functions that you're going to use a lot or other developers in the organization are going to need and saves time in development. And finally, one of the kind of the tricks, the sleight of hand that helps the user think that he's on a traditional app is updating the route. The route is basically the URL, so the address you see. And what a single-page app route engine will do is as you click on a view, it will go ahead and change that to a deep link such that if the user shared that link with somebody else or came back at some other time, they'll come right to that jumping off point. So these are kind of common components you'd expect to see in a single-page app framework. That said, that's really just scratching the surface. This is a screenshot of the Wikipedia page of different JavaScript frameworks comparing their different features. So it's a complex world out there. And often developers won't use one of the big frameworks. They'll actually build their own. There's actually some really good reasons why you might want to do that, which I'll talk about right now. So one of the biggest downsides with single-page apps is you can potentially have a lot of page bloat. These frameworks are big. They've got a lot of components. They're designed to make it easy for people, and so there's probably a lot of stuff in there that you may not need for your particular application. They can be 40K, even up to 100K, once you factored in the required components. So some of these frameworks are actually smaller than this, but they also require jQuery. So you have to actually include that in the must-have download. Now, from a performance perspective, typically, important optimization to think about is you want everything that's required to load the above the fold content for the user to be less than or equal to 14K. And the reason for that, that's basically one round trip. So that's, in theory, going lower than that doesn't save you a network trip. So that's kind of your optimization sweet spot. But as you can see, with these frameworks, that basically rules that out right off the bat. So for kind of a clean, an empty cache first page load, you're definitely going to have a slightly slower initial load with a single page app than you could get if you went and build your own framework. And I've heard talks out there, it's definitely possible to kind of cobble together or do your own single page app tool set under 14K. It can be done. But it's a lot more work and it's a lot more complexity for you as the developer. So these are trade-offs you're going to have to think about. Speaking of performance, wouldn't it be great if we had performance monitoring tools for single-page apps? That's what a couple of forward-thinking customers came and talked to me about some time back. And we said, OK, let's see what we can do here. But to understand why we embarked on this journey, first I need to tell you about why current tools don't get the job done. So the traditional model for monitoring performance is page view equals user experience. That's pretty much standard in the industry. We use it in our browser realm solution. Pretty much everybody thinks in this way. And the reason for that is it is a pretty good proxy. If you heard my earlier talk on synthetic, I said that onload is the worst measure of user experience, except for all the other available measures. So this is a functional model. It's worked for us. You can get this data across most browsers. Great. Unfortunately, single-page apps, as we've discussed, they don't load pages, not very many of them. So you're kind of a little bit blind to what's going on for most of your app. So this was kind of our first crack at this. We said, all right, single-page apps, people are interested. They seem to really use this Ajax thing. So what if we go ahead and wrap the XHR function and monitor that directly? Some other competitors took some approaches where they said, hey, well, maybe if we just take really long browser snapshots, we'll capture some of the goodness. And I'll say, this Ajax feature has been great. We hooked it up with BT correlation. People have solved some problems with it. It's been nice. But in the end, users were not particularly impressed. Because remember, these apps are complex. They're calling lots of Ajax. And you may have the same Ajax used in 100 different views. So without the context of which view, where in your code this Ajax is being called, it can be quite difficult to troubleshoot the problem. You could see that a particular Ajax fails 5% of the time. Maybe that's on one particular view, but it's kind of really tough to unravel that. So what we decided was we need to go back to the drawing board. We needed a new model for experience here. And so we said, OK, well, first principles. A good model is it measures what users actually see. That's the goal. So what we need is not page views equals user experience, but views equals user experience. That sounds pretty familiar, actually. And as you find, everything old is new once again. Now, the screenshot I wanted to use here, fortunately, the legal department wasn't a big fan of my using that, so I had to redact that. But mad geek props if you catch the reference here. OK, so here's AppDynamics model. We basically build a hierarchy. It's built on this concept we're calling the virtual page. That's basically what equals a view, which is what we believe equals user experience. And then Ajax is the data layer. So we're building a mapping between virtual views and Ajax requests. The nice thing about this model is it's extendable. So as we get into things like page components, often you may load a specific facet of your page. So we can slot things like that into the model as well and expand it. Ajax as a data layer does raise one interesting contradiction. Ajax literally stands for asynchronous JavaScript and XML. However, in a single page app, often these Ajax requests are synchronous from the user's perspective. You can't actually load that view without updating the price for the quote. So that effectively becomes a blocking request. So it's kind of interesting, that Ajax is kind of adapted to be used in a way it wasn't probably really intended. So that's something that you need to think about as a developer. We'll talk about some of the ways we try and sort that out with some code examples in a minute. So here's our progress to date with this model. As of 4.1, our currently shipping code, we have automatic instrumentation of Angular. So basically, if you use Angular's UI router or ng router, those are route updates, as I discussed. We'll actually hook into those and start a virtual page. And when that completes, we can time that. So that's good. And to be honest, we did that because we had some key opportunities, and we happen to use Angular in our own application, so this has made sense as a starting place. And then, of course, we can associate Ajax requests based on time. So we're looking at what Ajax requests are going on as a virtual page is being loaded, and we say those are probably relevant or interesting. So let's flag those as being pertinent to that view. So you would get a screenshot like this, and then on the bottom you see a list of related Ajax. I'll show you a live demo of this in a minute, I hope, knock on wood. And what we found is we were really just in time because Angular and really all the other frameworks, the adoption of them is just suddenly really dramatically picking up in the marketplace. So Angular was a good starting place that made some customers happy. But what about this? What about everybody else using all this other stuff in the ecosystem? We needed an approach, and we said to ourselves, doing automatic instrumentation one by one for each one of these, that's going to take us a while. We're definitely going to invest more in automatic. But maybe there's an interim step that we can get out there that will give value to anyone who's got a single-page app framework. So in 4.2, what we're bringing out is a manual API. And this will let you add code to your application to report those virtual pages and associate Ajax with them. So here's kind of the fundamental element. As you see in line 1 here, we're basically defining a tracker using the add/rum JavaScript API. And you can just call this, or you could pass it a specific URL to use in the naming of it. And you can start to see associate things like parent events. Let's look at a more interesting example. This is just basically a wine details view that a simple demo app we've had. You may have seen it earlier if you came by our demo session. And so as you see at the start of the function in line 2, we go ahead and create that view tracker. And then going down to 3 and 7 and 8, what you see is we're basically marking key events within this code. Now, this is a fairly simple view, but as you can imagine, if there is a big difference between when XHRs are completed and the DOM is fully updated and loaded, you can start to see the differences in those times. So this will kind of help you figure out where in your code potential slowness is going on. Then at the end, once you've done all those marks, line 12, you can go ahead and report that. So we save you the effort of packaging up and sending that beacon. You just say, hey, this tracker's done, send it on, and we'll beacon that into our system, and eventually it'll show up in your controller. All right, so let's come back to that tricky issue. Which Ajax should be related? Now, as I mentioned, we're basically using time, which is a pretty good proxy. Things are going on. It's kind of guilt by association. But there's some pretty clear examples where actually there isn't an ownership there. One is keep alives. And the other is potentially you can have different views concurrently loading at the same time. So you need a way to kind of unwind those. I think this is going to be a continual journey for us, but the 2 initial solutions we've come up with is you can exclude and include, and then you can kind of manually turn on and turn off the association of Ajaxes with a particular virtual page tracker. So let's look at the first one. Basically what you have here is a little bit of snippet of JavaScript you can drop in your page. And what this says is basically for single-page apps, Angular, virtual pages, look at XHRs and exclude any URLs that have this pattern in the URL, in this case, a keep alive. So what this would do, if you called this on a particular page, is it would ignore those keep alives for purposes of associating with virtual pages. Now, we'd still go ahead and collect metrics on that keep alive, but we don't get that into the details for the view. Here's a manual example. So again, we're defining a virtual page view, and then what we do actually when we create these view trackers is that we actually automatically call this start correlating XHRs function. But if you want to turn that off, you can just simply call the stop version of that right away. And then in this case, we're following a keep alive Ajax, which we didn't want to include. And then when that's been called, we turn it back on. Because keep in mind, the way we are detecting Ajax is we've wrapped the function. So when we see it's called, that's when we know to associate it. So it doesn't matter if this keep alive came back after line 8. Once we've missed the initial call, that will be safely excluded. All right. So in sum, there are a number of things you can do with virtual pages. They're plugged into our health rules and policy system, so you can set up a rule and alert and get trending on the performance of your different views. You can start to set up organizational SLAs or policies on these. where you see a problem, you can see the underlying network calls and rule them out as a source of the issue, or where there is a problem with BT correlation, you can drill into the back end. And then, as you see in a moment, we're basically treating virtual pages as a page for purposes of features like sessions. So if you go and load a session, you'll see a sequence of pages and potentially virtual pages telling you where the user's clicking and how they're behaving. So, internet and Wi-Fi willing, what I'd like to do now is show you a quick demo. Go away, HipChat. I don't need you right now. Okay, so this is your controller view, and if you had a single page app and you'd instrumented with us before, this is similar to something you might have seen. There's one page. It's very sad and lonely. There's not much going on here. However, now I can come up and turn on virtual pages, and now it's got a lot of friends. So there's lots going on here, and these are all, works very similar to the traditional page dashboard with metrics and health rules behind this data. So let's maybe go into this main dashboard view. Oh, good, the Wi-Fi is working. And so as you see, we can start to trend over time. My trend line isn't very exciting because I have a developer clicking around in this app, but your users will help you out with that problem. You can see things like digest cycles for Angular in particular. And then, as you see here, here's a list of different Ajax that are being typically called on this page. So as you can see, it can be quite complicated. Lots of Ajax going on with a real working single page app. So that's cool. You might want to go down to a particular snapshot. So I'll do that here. All right, here's an interesting one. Let's grab that guy. So again, this is now an individual data point for this single page app. And you see the specific Ajax that are being called for this guy. And where there's BT correlation for one of these, I can see this blue flag here. So if I saw that this was a slow Ajax request, I could hop over here, and I see the canonical business transaction. I'll always have this information. But where there's a transaction snapshot, because remember, we don't always collect those to keep overhead low. But whether one exists, that'll show up here, and I can click through, and now I'm in the back end. Let's back up out of there. Another feature you may have noticed is view session. So I actually can link directly into the session record for this virtual page. And if I click on these, it will load a waterfall. Now, note, this is not an actual page load. These are actually different Ajax requests being made. But we've chosen to represent this as a traditional page waterfall. You can see the different drill downs into the Ajax requests. And again, where there is a transaction snapshot associated with that, I can click through into the backend product. Very cool. This is kind of useful. Let me take away some of this clutter here so you can kind of see what's going on a little bit better. Basically, as you see, is we have a playback of the user session within this view. So literally, this is actually AppDynamics, monitoring AppDynamics, watching AppDynamics. So this is actually a kind of a vicious circle here. But you see somebody's gone to the controller. Looks like we didn't put a name for that page. It went to the end-user monitoring dashboard. We clicked around the dashboard, and eventually they got down to session analytics. And so you can kind of see the different steps users took. Let's spend a little more time with sessions here. So hopping over here to the Sessions tab. So I showed you how you could jump from a snapshot to a particular session, but you can also go directly in. So here we basically see this is part of the reuser monitoring product. You have basically a data visualization view into your session data. This is not going to be super exciting, obviously, because it's just one developer doing things. But as you see, you can get different dashboards and reports, and this is all filterable. So if I just wanted to look at data for like the main dashboard, I can click that, and then I can see the sessions that touch that particular view over time, the different user devices and locations. So this is handy from an analysis perspective. I can also go over to the Data tab and search and discover different virtual pages. So like I could open up the same view you saw before by clicking on this one, and I get the waterfall view for each different individual step. I can also go down and filter this. So like potentially, let's say I only wanted to look at sessions for Linux users for some reason, or sessions for a particular region. I can filter that like so, and then now I'm seeing a subset of my data. One of the cool things we have for the sessions feature is the ability to go in and enrich it with your own custom data. So we actually have had this user data API for a long time, and this lets you basically add any key value pair. So potentially you could do something like user ID or company or A/B test scenario. Really, it's whatever is relevant to your business. And now those would basically show up here as fields that you can search and filter on and retrieve it. So this works all for the standard browser RUM, but what I really want to show you is that virtual page apps, single page apps are getting the same treatment as traditional apps with our new features. Last thing I want to show you real quick is just the health rule section. So I can go in here to the health rule section, and under web end user experience, you'll see that virtual pages shows up as an option I can click. I'll name this test rule, and then I could have this touch all virtual pages, or I could set up different health rules for specific virtual pages. And now, it's just as you're familiar with, I can define critical and warning conditions based on things like end-user response time, how much requests are being made, the DOM time. Basically, the metrics you want to benchmark, you can tie health rules to. Great. So with that little demo done, I can exit that. So we definitely have some time. I can give you early crack on lunch, but I do want to open it up for any questions that may be in the audience. Yes. The question is, how does licensing work for single-page apps? We basically treat a virtual page as a page, and that also goes for licensing as well. So our browser RUM licensing is based on page views, and so virtual pages are just treated that from a quota perspective. Yeah, primarily that's a commercial discussion your sales rep would have, if you have, pre-prod and prod environment, and we're happy to have those conversations with you. But from how the product works, basically, each license gives you 10 million page views, and so regular pages and virtual pages both hit that quota. Yeah, go ahead.
Is this so it's for mobile as well as for web? Is it available 4.1 or?
Yeah, so exclusive of Angular, which works today, the manual API that I showed you the code examples, that's a feature for 4.2. So it's coming. And yes, we don't care, just like our regular browser RUM product, we don't care what the user agent is. If you have it on a desktop or on your phone, or even if you're loading web views in a native app, we can go in and instrument that and collect virtual page data on those. So in 4.1, we support Angular. 4.2, we provide the manual API that you could use for any virtual page app. Or in theory, if you're doing something that's not a single page app, but it has a JavaScript runtime, potentially you could use this as well. OK, I think there's some question. I thought I saw one there. I'm sorry, can you repeat your question? Where our virtual page is hosted? So the way our architecture works is you put a JavaScript agent into the browser. That then instruments and collects virtual page data. Then when you call that beacon command I showed you at the end, that will send our own Ajax request, actually, to the cloud. Or if you're an on-premise customer, it goes to your on-premise collector. The collector basically processes that and then the controller queries that for data every minute. There's some more complexity once you get into analytics and sessions, but I'm not sure I fully answered your question. Yeah. Ah. I see. That's just an artifact of the demo. The developer is running this application on his local host. So normally that would be like appdynamics.com or usa.com, in that URL. So basically that column was a sequence of URLs. So it's not, we don't host your application code. We just are piggybacking using the JavaScript agent. Maybe we can talk after, I think. Yes? Mm-hmm. Great question. So session demarks basically. Oh, we're running out of time? Oh, yes, thank you, Peter. Sorry. Let me repeat the question. Basically, what you have a user who basically is refreshing, doing a hard reset mid-session, or maybe he gets up and takes a coffee break and then comes back and continues the session. But when does a session start and end? Basically, we give a configurable time. So you basically say, 15 minutes of inactivity, that's when I want to stop a session. So as we're getting these beacons in the cloud, we're basically saying, okay, still part of a session, still part of a session. We're bringing them up. We've basically used data and local storage to create a session identifier. And then anything that has that session identifier is going to be joined. Now, I'm pretty sure that F5 doesn't clear local store. And so in that particular case, you'd be fine. So I don't see an issue there. Basically, you can tune that timeout based on your app and users. So some apps, you want to have really long sessions, you could set that timeout longer. You may set it for something like 5 minutes of inactivity. Answer your question? Awesome. Yes? The question is, why not use the session ID provided by the app? We actually wanted something locally that we can control. And actually, the developers can probably get into that trade-off a little bit more for you. So let me kind of duck that question. And come on up, Anil. All right, yes. Do you want me to repeat that? Just okay. Yep. So, thank you. I had a brain fart. I knew this answer. I really did. Basically, that session ID is generated once you've logged in as a user potentially, right? But you want to have visibility into activity that's going prior to, say, the checkout event. So if I go to your site, I'm browsing around, I'm adding stuff to the cart, I'm not logged in. Then I log in. Now I have that session ID. But that's kind of almost too late to start doing the sessionization. And also, not all apps have that model. We needed a more, a broader solution that didn't depend on the back end per se. Mm-hmm. Cool. Other questions? Okay. Thank you all for coming out here.